Hello there, everybody, and welcome back. Root Beer here, looking at question number 3 on the Manitoba Math Contest from 2016. So, we got a two-part question here. 3A, two concentric circles have center O. A chord AB of the large circle is tangent to the smaller circle and has length 10. What is the area of the ring between the circles? Okay, so the ring, also called an annulus, has a nice little formula. If we know the radii of the outer circle and the inner circles, so if I have something like R and maybe big R, then the shaded area here, this sort of donut-looking shape, area is just the big circle, pi r squared, minus the hole that we cut out, which is the little circle. So if I could figure out the radius of the big circle and the radius of the small circle, I'd be all set. Or, since I don't think I have enough information to do that, if I can just figure out the expression, the big radius squared minus the little radius squared, that would be enough, because that's all I really need to get this area here, based on the formula. Okay, but what are we to do? Well, take a look at our picture here. We have a radius of 10 here, but it's tangent. And what do we do with tangents? Also, I want to draw the small circle a little bit bigger. Anytime you have a tangent to a circle, you should automatically connect up its radius, because you'll get a right angle, and that can be incredibly useful. Okay. Not only that, but because these guys are concentric, you can make the argument that it splits the chord in half. So it's actually a 5 and a 5 here. A more precise statement of that would be extend this radius out to a radius of the full big circle. Because it's a chord, and the radius of the big circle hits this at a perpendicular angle, we know that it splits this into two equal parts. Okay, what else can we do? Well, I'm looking for big radius squared minus little radius squared, and that puts me in mind of Pythagoras. So let's connect that up, and suddenly, by Pythagoras, so by the Pythagorean theorem, we have r squared minus little r squared has got to be 5 squared. Well, that's all I need. My area is now pi 5 squared, or 25 pi. Okay. So 25 pi, not bad, not bad. Let's take a look at B now. So B, we got a nice little picture. Two circles intersect at points A and B. The length of the arc AB on the smaller circle, so distance from A to B, but we have to travel along the circumference of the smaller circle, is 1/4 of the circumference. Okay. The length of the corresponding arc on the larger circle is 1/3 of its circumference. If the area of the smaller circle is 12, what is the area of the larger circle? Okay. Well, they've given me at least enough information to talk about the radius of the smaller circle, because we know that that's 12, don't we? So from there, I guess we can get the radius. And then we have to say, all right, how does the radius relate to things like, well, the circumference? Well, we know that. And then we know that distance from A to B there. And then how do we relate that to the area of the largest circle? So I'll tell you what, we're going to draw the picture here. And I probably need some more space, so we'll go over a page. All right, so small circle, big circle, A, B, and we know the area of this one here is 12. So we'll once again call this radius R and this one big R. If I can figure out big R, I can get the radius of the big, or sorry, not the radius, the area of the big circle. It's pi r squared. But we know the small circle is 12 pi r squared. So r is, I guess, 12 over pi square rooted. Which I guess we can write as 2 root 3 over root pi, but I have a feeling we're not going to be using r itself in this form. We'll probably just keep r through our equations. So now that I know what r is, I can figure out things like the circumference of the small circle. Now, this gives me a section, sort of like a slice out of the small circle. So what I'm going to do is I'm actually just going to add radii to both A and B. And this is probably something I want to do on both of the circles. Because there is a nice relationship between this angle, we'll call one of them theta and the other one will be, now we'll call one of them alpha, one of them beta. Because if I have a section of the circumference, alpha over 360 times the circumference is equal to the arc length of AB on the small circle. And actually, I guess I don't need the circumference. I thought I'd need to rearrange with r and get the circumference. Turns out I don't, because we know that this is 1/4 of the circumference of the small circle. And so from there, we can figure out alpha is 90 degrees. Similarly, we know beta over 360 degrees is going to be 1/6, because the circumferences will drop out of a similar equation. That tells me beta is 60 degrees. Okay, that's all well and good, but I still need the area of the larger circle. Okay, so I still sort of need to get capital R. Maybe not capital R itself, but maybe capital R in terms of little r. You know, maybe it's twice little r or something like that. Now, unfortunately, I can't say that these two lengths here are equal, but maybe we can draw a picture. Well, we have a picture, but let's connect up the radii here. So okay, hold on, no, wrong connection to make, that's okay. While I can't say that the arc lengths are the same, I can say that the length between A and B is the same. And now I can say, okay, AB squared is r squared plus r squared by Pythagoras. And I can also get it in terms of 60. AB squared is capital R squared plus capital R squared minus 2r cos 60 by the cosine law, which we remember from an earlier grade, most likely grade 10, but I'm not up on my Manitoba curriculum. But now I have two expressions here. Cosine of 60 degrees is something. I'm trying to remember what. I think it's 1/2. Yes, cosine will be the smaller one there. So it's 1/2, so AB squared is just r squared plus r squared minus the 2 and the half will cancel out, so minus r squared. So it'll just be r squared. So 2 little r squared is equal to capital R squared. I didn't need little r at all, because, and this seems like a waste of paper now, so we'll write it big. So 2r squared is capital R squared. And the area of the large circle is pi capital R squared. But of course that's pi 2 little r squared, which is 2 times pi little r squared. And we know that that's 12. So it's 24. Alright, so 24 is the area of the large circle. That wasn't so bad. We just had to connect up A and B. Alright, so we'll be moving right along to question number 4 in the next video. Hopefully you guys will join me for that one. And, or feel free to skip ahead and take a look at, maybe 6 is the next one you want to see. I look forward to seeing you guys there as well. But in the meantime, have yourselves a wonderful day, and I will see you later.